So now we have the tools to address a couple of common popular themes for AP free response questions. So what you see here is a graph. And so one of the main things that you should notice when you see a graph that's a bunch of lines and often semicircles, a lot of times they're going to be wanting you to find the area under the curve. Like that's just a given. Like you see that, like, oh, I'm going to have to find the area of this trapezoid right here and probably this trapezoid over here. All right, and that's going to be useful to answer some of the questions. All right, a lot of times, again, there'll be a semicircle because there are things you can calculate the area of. When they do that, they're going to specifically say things like the function g is piecewise linear, even though we can clearly see that g is piecewise linear from -5 to 3, right? But they have to say that because just because this looks like a line, you cannot assume that it's a line just because it looks like one. So they're going to tell you it's linear. That means these are in fact lines. They're not maybe like really tight cubics that you can't distinguish from a line, okay? So because that could happen. All right, so what can we do with this kind of thing? Other kinds of really important information to focus in on is, what have you got a graph of? What are they asking you about? They gave you a graph of g, like really focus in on that title. Then they're asking you about the function f. What is the relationship between f and g? G is the derivative of f. So they love to tell you that and tell you that sometimes in disguised forms that we'll see later. So when we see that g is the derivative of f, I highly recommend on this g write equals f prime. So we know this is a graph of f prime and it's also a graph of g itself. You've got to be aware of the difference between the graph of the derivative and the graph of the function. This one's asking you about the graph of the derivative, or actually this one's asking about the function whose derivative is shown. So it's really, when this is asking a question about f, they gave you about f prime, they're really asking about an antiderivative, which is an integral. So here's what they tell you. They tell you f1 is equal to 3, and they ask you, what is f of -5? What is f of -5? All right, so it's very typical. What they've done is they've given you a known value, they've asked you about an unknown value, and they've given you something that describes the rate of change of the function. That's what tells you that you should be thinking of f of b equals f of a plus the integral from a to b of f prime of x dx. All right, I'm using x dx this time instead of t dt because x is the independent variable. So I try to match that variable. Of course, if you put that t, you're going to still get it right. All right, so now there are various ways to do this. One is we can say, what I personally prefer to say is that whatever value of x is smallest, we should call a. And whichever value of x is largest, we should call b. That's just consistent with that we usually talk about an interval from a to b. So then what I would have in this setup is f of 1 equals f of -5 plus the integral from the integral from -5 to 1 of f prime of x dx. All right, so this is one way you can write it. And so in this sense, you know what f of 3 is, and you're calculating f of -5, and then we just have to get a handle on what this integral is. So there is another way to do it, by the way, which is that people will say, okay, we can say, if you want, f of -5 equals f of 1 plus the integral from 1 to -5 of f of x dx. All right, you can say that. And it has the advantage of we're looking for f of -5, and that's what's isolated in the equation. The disadvantage is you have to notice that the lower limit of the integral is larger than the upper limit, which is okay as long as you flip that integral over and put a minus sign in front. And you can take a moment if you like to confirm that algebraically this equation, f of -5 equals f of 1 minus the integral, is algebraically equivalent to this one, f of 1 equals f of -5 plus the integral. So I like this way because you always put the lower limit, the lower number as the lower limit, and I just formally prefer that. But you can do it either way. People do it either way. All right, so now we have to get a handle on what this integral is. What is the integral from -5 to 1? We don't know. Look, we don't even know what the function f is. We know what g is. Could we use g, and since g is the derivative of f, could we get what the f is? You could, but you absolutely do not want to. All right, if I want to know the integral from -5 to f prime to 1 of some function, and they gave me a graph of that function, and from -5 to 1, that function is linear, all right, I can just add up the areas. It's much easier. Now, when I do that, I have to bear in mind that all this area down here is negative, okay, and then this area up here, I'll make that pink, I guess, is positive, all right? So let's call this area in here area 1, and we'll call this one area 2. All right. So the integral from -5 to 1 of f prime, because this is a graph of f prime, is equal to the negative area 1 plus the positive area 2. And so that's combining a lot of things that we know about, like areas under curves. When we treat the area below the graph as negative, lots of things are going on there. And then you can use the areas to get the integrals instead of using the integral to get the area. In a way, that's what this simplified linear function is cueing you to do, is that instead of getting the area using the integral, you're going to get the integral using the area. Sometimes it's much easier, as in this case. Sometimes it would be impossible to do any other way. Sometimes, because they gave you this function, yeah, you could figure out what f is, all right, but you don't need to. So because now we can say 3 equals f of -5, and then area 1 is, now notice what else they do. I'll just take some time to point this out because they do it all the time. And if you get quick at noticing it, look how the grids are all 1 by 1, right? 1 by 1 every direction. They do that all the time. So you don't have to sit there and figure out this area. Look, it's a 3 by 3 square. The area is 9, all right? This is a 1 by 3 rectangle. We got half of it, so the area is 3/2. All right, so that this negative area, so we're going to have -9 minus 3/2. And then for our positive area, we've got half of 1 by 2, so it's 1 plus 1. All right, now you can do a lot of different ways to work this out, but let me also point out to you that in a free response question, you do not have to simplify your answer. So you can go like this: 3 plus 9 plus 3/2 minus 1 equals f of -5. I've isolated what f of -5 is. I've reduced it to a simple computation. I'm done. You do not have to simplify that. All right? Yeah, did I do the sign things right? Yeah, I did. Okay. So then what do you get? You get, so you don't have to do anything more, but I'm going to because I can't help it. So this is going to be 1/2 plus 12, so it's 12.5. Right, it's 12.5 is equal to f of -5. But I'm pointing out that you don't have to simplify it. Okay, so that's number 3, part A. And the key here is when you have a linear figure like this, use the areas to get the integral, not the other way around. All right, we're going to do part B next. If you want to, have a look at part B and just go ahead and do it.